Tali, and I am a junior in the College of Engineering at the University of Michigan studying civil engineering. This summer I had the opportunity to conduct research in the Civil and Engineering Department through the Summer Undergraduate Research Experience here at the University of Michigan. I worked with Professor Jason McCormick and his PhD student Dan Way in the field of structural and materials engineering. I was able to work on two different projects which gave me two different perspectives on what research involves. The first project was a lot more computer-based, and it involved exploring the differences between the American standards and the international standards. Chord sidewall failure limit state equations for HSS tubes in a T-joint truss connection with a branch to chord width ratio of beta equals 1 with the branch in compression. Sounds very confusing, but it actually wasn't that bad. It started with some Excel spreadsheet calculations to find out what exactly these differences were numerically, and the differences were so vast that I ended up reading a bunch of research papers to more explore this chord sidewall failure phenomenon, and this in turn led to a full-blown parametric study using finite element analysis with the Abacus software. What was really cool was I learned a lot about this chord sidewall failure and steel design equations in general, and I also learned a lot about the Abacus software and finite element analysis, which is something that a lot of undergraduates in the civil engineering department here don't have a lot of experience in. So I was pretty fortunate to get that under my belt this summer. The second project was a lot more hands-on. Professor McCormick's main research interest lies in earthquake engineering, and currently he and Dan are looking into the use of non-traditional materials in HSS tubes in order to reduce the damage caused by earthquakes on buildings using these tubes in their design by filling the tubes with materials such as foam or rubber, because it has high damping qualities which can reduce the amount of time that the vibrations are felt for. So my part in this was to perform some lab tests on HSS tubes. I got to work with 5-foot-long tubes that were 4x4, 5x5 wide, and fill them with foam and perform monotonic and cyclic bending tests on them to see how their structural response varies from being empty to being filled with foam under these types of loading. What was really cool was that I got to use the big machines in the structures lab in G.G. Brown, and I got to do a lot of hands-on work and preparation for these tests. And every now and again I also got to do some outreach activities which were a lot of fun, and I met a lot of pretty smart kids who may even be potential future engineers. So I really enjoyed that aspect of my summer also. So all in all, it was a great way to spend my summer in Ann Arbor.